Right, so we're now going to learn our last method of how to graph. And like I said before, you can choose whichever method you think is best and easiest for you. And there's times where some methods are just easier and allow themselves to be graphed easier than others, but ultimately it's up to you. So the last one to go through is our standard form, and this is our section 2D, so the fourth section of our second unit. And what you'll need to learn or know by the end of this video is you'll have to know what an x-intercept is. So we already talked about what a y-intercept is, and hopefully if you know and can identify what a y-intercept is without me explaining, maybe you can identify what an x-intercept is. You'll have to know how to rearrange an equation from standard form to slope-intercept form. And then last thing is you will have to know how to graph an equation when given x and y intercepts. And that's essentially what we do when we're graphing from the standard form. All right, so these are the three things that you will have to know. Let's go ahead and talk about a few things first before we get into graphing in this method. All right, so remember, we talked about what the y-intercept is, and that's where the line crosses our y-axis. And we knew that when we have a y-intercept, our point is 0, comma b, where b represents our y-intercept. So the same thing is true for our x-intercept, except for it's where we cross our x-axis. So it's where our graph crosses our x-axis. And if our x value for a y-intercept is 0, well, our y value for our x-intercept is 0, because as I talked about in the other video, we know that we start from our origin. If we don't move up or down from that origin, our y value remains 0. So if we start from our origin here and we only move left or right and cross at this x-axis, our x value will change, but our y will remain 0 because we never moved up or down from that origin. And the way that we can denote that from a letter is A, representing our x-intercept. And if you wrote x comma 0, I would accept that as well when you're talking about this, but just all you have to be able to identify is with our x-intercept, we set our y equal to 0. And for our y-intercept, we set our x equal to 0. And that's what you must be able to remember. And a lot of times is when people see x-intercept, they want to set x equal to 0 because they see the x. But just remember that it's the opposite one that we set equal to 0, because when we're crossing our x-axis, our y value never moved up or down, so that's why it's 0. And when we cross our y-axis, our x value never moved left or right, so that's why our x value is 0. All right, now let's go ahead and see what it looks like, standard form, and then we'll go ahead and graph a few. So our standard form, and this should be written as capital, so our standard form is ax plus by is equal to c. So you see here in our slope-intercept form, it was set equal to y. We had y is equal to mx plus b. And our standard form is where it's set equal to our constant. So our c represents that constant, and we have our x and our y are either being added or subtracted to each other. But the main thing is a and b cannot be 0, because if it's 0, then 0 times anything we know is going to eliminate it, and it will actually either just create a vertical or horizontal line. So a standard form is ax plus by is equal to c. So in this case, we have our x's and our y's on the same side of the equation, and it's set equal to our constant. Our slope-intercept, here we have it set equal to our y, and we know that we're given our slope and our y value, or I'm sorry, slope and our y-intercept. In our standard form, it's set equal to a constant. So that's what you must be able to identify. All right, so now we're going to go ahead and show you how we can graph in this form. And like I said before, when you're given a question on your test and you're asked to graph, ultimately you have complete freedom of how you want to graph. And it's up to you on which method you find to be the easiest to do. And I'll show you some examples of where it's easier maybe in standard form and maybe easier to rewrite it in slope-intercept. All right, so when you're asked to graph, as I said in the last video, all you need is 2 points to actually make a line. In the table, I have you do more than 2 to make sure you don't make any mistakes, so your graph is actually accurate. In the one where we have our slope-intercept, I asked you to do 3, so that this way, once again, you can avoid from making mistakes. When you're using the standard form, what you're going to do is you're going to find your x-intercept. So I'll do this on this side, and then you're going to find your y-intercept. And when you find those 2 points, you plot them and you just draw your graph. So remember, when we're finding our x-intercept, we set y equal to 0. So what that means is y is equal to 0. So I'm going to substitute 0 in for y. So negative 2x plus 3 times 0 is equal to negative 6. So when I substitute this value in, I can then solve and figure out what x is equal to know what my x-intercept is. So this then simplifies, and negative 2x is equal to negative 6. I divide each side by -2, and x is then equal to a positive 3. So my x-intercept is 3, 0. So I can go ahead and plot that point at 3, 0, because that is where it crosses my x-axis. All right, so now I'm going to go ahead and do my y-intercept, and my y-intercept, I set x equal to 0. So if x is equal to 0, I plug it into my equation, I substitute. So -2 times 0 plus 3y is equal to -6. Well, this is going to give me 0, so now I'm left with 3y is equal to -6. Divide each side by 3, y is then equal to -2, and that generates the point of 0, -2, because x was 0, and our y value was -2. So I can go ahead and plot that point of 0, -2. And once we have those 2 points, we can go ahead and draw our graph. All right, and you guys will use a straight edge, like I always say, so this way you know it's drawn accurately and correct. All right, so that is how you can graph in standard form. I'm going to go ahead and redo this question for you and show you how you can actually, if you prefer, graph this in slope-intercept form. All right, so I kept the graph on here just to show you that it's going to give us the same graph no matter which way you choose to graph. Let me go ahead and make this a little bit skinnier so this way I can fit my work here. So if we have this -2x plus 3y is equal to -6. So if you wanted to graph this using our slope-intercept form, we need to rewrite it as y is equal to mx plus b. So we need to isolate our y and solve for a y like we were doing in our last unit. So to do that, to get y all by itself, I would need to move this x to the other side of the equation. So now I have 3y is equal to 2x, plus, 2x minus 6. All right, and since we know that our y-intercept, slope-intercept form is written mx plus b, we're going to write our x first. So even if this was a negative, we would still write that first. And then the last thing we need to do is we need to isolate that y. So I need to get rid of that times 3. And to do that, I will divide each side by 3. So now I have y is equal to 2x minus 6 over 3. Now I told you in the last unit that you could leave it like this for now. However, once we get into graphing in standard form, we need to separate these. So I actually need to create 2 different fractions. I'm going to create the one there with my x and my 3, and I'm going to create another one with this -6 and 3. So I'm going to actually separate these. So I will have y is equal to 2x over 3 minus 6 over 3, and I will look to simplify. 2 over 3 can't simplify, so it's 2/3 x, and 6 over 3 actually reduces to 2, so it is -2. So I'm going to go ahead and graph this using a black point, and you'll see my y-intercept is -2, so there's my y-intercept. My slope is 2 over 3, so that means I'm going up 2, so I'm counting up 1, 2. Let me use a thinner. So I'm counting up 2, so 1, 2, and I'm going over 3, 1, 2, 3. You see how it falls right on that same point. So when we go to graph this line, it's going to draw the exact same graph that we just did. So you can see that no matter which method you choose, it is going to give us the exact same graph. So you see, I'm going to go ahead and graph this just to show you that they will fall exactly on top of each other. All right, so it doesn't matter which method you choose. And I'm going to go through one of the ways at the end of this video of maybe when this standard form doesn't really work, or it's not easy. All right, so there's one more question that we're going to do just using standard form, and I'll show you when it doesn't really work. All right, so same thing here. We're graphing using our standard form. So we have our x-intercept, and we have our y-intercept. We know our x-intercept, we need to set y equal to 0. So in the equation, y will be 0. So if y is equal to 0, we have x plus 3 times 0 is equal to -3. So then I have x is equal to -3, which then generates the point of -3, 0, because y is 0 and x is -3. So I can go ahead and plot that. Here is -3, 0. And then I'm going to do my y-intercept where we set x equal to 0. So if x is 0, we have 0 plus 3y is equal to -3. So 3y is equal to -3. Divide each side by 3, and y is equal to -1. So we have the point of 0, -1, because x is 0, and y is -1 when x is 0. So I can go ahead and plot that point of 0, -1. Once we plot those 2 points, that's all that we need to do. We can draw a line going through that now. So I'm going to go ahead and draw that. And there would be my graph. All right, so it's really not that hard either when you're doing this. If you're choosing to use this method, it can be quite simple. One of the mistakes I see, though, is that people will set x equal to 0 for x-intercept, so make sure you're doing it properly where it's the opposite variable is what we set equal to 0. All right, and then there's just one other thing I'm going to show you real quick as to when this one might not necessarily be that easy to use, and when you would probably should rewrite it in slope-intercept form or use a table. All right, so the first example we did, we had negative 2x plus 3y is equal to negative 6. And if you notice, both of the coefficients that we had divided evenly into that constant. 6 could divide evenly by 2. And our other one, 6 could also be divided evenly by 3. And the same thing held true with our next one. This was a coefficient of 1, so negative 3 was divisible by 1. And we had positive 3, and so that means negative 3 was also divisible by 3. But what if I give you a problem that was 3x plus 4y is equal to 11. So if you were to try and do your x-intercept and y-intercept for this, you'll notice that here, when y is equal to 0, we would get 3x plus 4 times 0 is equal to 11. And we get 3x is equal to 11. We're not going to get an easy number to graph. It's going to be 11 over 3, which then means we're going to have to approximate our point. So when these coefficients can't divide, when they both can't divide evenly into that constant, it's probably best not to use this method because then you're going to be approximating your graph. And since we can use more precise methods, it'll be easier or better for you to just rewrite this or use a table. So like I was saying as well, if we try to find our y-intercept and we set x equal to 0, we would get 3 times 0 plus 4y is equal to 11. We get 4y is equal to 11. When we divide each side by 4, y is equal to 11 over 4, or approximately 2.75. So in both of these cases, we're going to be approximating our graph. And you can still graph it really close and still be accurate. But it just might be a little bit harder for you if you're not very good at determining what is 0.75 between one of those tick marks. So that's when you probably wouldn't use this method, and that you would rewrite it into your y is equal to mx plus b, or you would use a table of x and y to generate some values. All right, so that is it for this video.